Hi students, small request Nana. Without subscribing my channel, you are watching my videos students. Please subscribe my channel. Please support me Nana. Then I can do more videos. Please Nana, please. Thank you students. In today's session, I'm going to discuss about the VBT, Valence Bond Theory, 12th class topic, lesson name coordination compound students. Okay, this is the complex, this is the trick box. First, we have to find the oxidation number of the central metal atom. Now, you have second trick is you have to identify the ligand. It is a strong field ligand or weak field ligand. Okay, so if it is strong field ligand, these are the examples: NH3Cn minus, weak field ligand fluoride and chloride students. If it is strong field ligand, 3d electrons pair up Nana. If it is weak field ligand, 3d electrons do not pair up students. Okay, that you have to remember in this trick box. Now see, first what is the trick one? Calculate oxidation number of the central metal atom. So I'm going to calculate the oxidation number of the central atom. So I'm taking the nickel. Nickel is the central metal atom. It is the ligand. Ligand is nothing but it is ready to donate the pair of electrons to the central metal atom. See here, central metal atom is actually metals are ready to lose electrons. So because of loss of electrons, they becomes electron deficient. So that's why they are ready to accept the electrons. That's why here the central metal atom is ready to accept the electrons from the donor. So Cn minus cyanide is the donor. It is the ligand. Clear? So first central metal atom oxidation number I am going to calculate. Nickel oxidation number. So I am taking as X Nana, nickel oxidation number plus 4 cyanides are there. 4 into cyanide oxidation number minus 1. Here charge is minus 2 is there right here. Then X minus 4 is equal to minus 2. Understanding? Minus 2. Then what you will get? X is equal to minus 4, minus 2 plus 4, you will get the plus 2 oxidation number. Okay, plus 2. Now atomic number, how much Nana? Nickel atomic number you take first. Okay, X is nothing but here 2 plus 2 kada. This is the nickel oxidation number plus 2. Okay, nickel atomic number, tell me Nana. Nickel atomic number: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel. 28. So nickel atomic number 28. Electronic configuration argon 4s2 3d 8 Nana. Are you clear? Argon 4s2 3d 8. See here how much oxidation number plus 2 is there. Correct? How oxidation number is plus 2 Nana. So plus 2 is nothing but 2 electrons lost. Nickel atom lost 2 electrons Nana. Okay na? So that's why here what is the electronic configuration Nana? Nickel by loss of 2 electrons. Loss of 2 electrons, it is losing electrons from the fourth shell students, fourth shell. So that's why electronic configuration argon 3d8 4s0 students. Are you clear? 3d8 4s0. So this is the Ni plus 2 electronic configuration. Now I am taking the orbital structure 3d8 4s0 Ni plus 2. Okay, see here Ni plus 2 orbital structure 3d8 4s0. So I am taking 3d8 1 2 3 4 5 1 2 3 4 5. This is 3d and this one is 4s. Okay, now see students, in 3d how many electrons there? 8 electrons are there. So I am taking 8 electrons 1 2 3 4 5 6 7 8. Okay, total 8 electrons there. 4s is completely vacant Nana. So here no electrons. Now second trick is ligand. You have to identify students. It is strong or weak ligand. Yes, Cn minus is the strong ligand. Correct? It is a strong ligand. So strong field ligand. So that's a 3d electrons pair up Nana. So that's why here 3d electrons already paired 3d electrons. These two are unpaired. That's why here these electrons will come to here, it will get paired. Are you understanding? So because of strong ligand, so that's why here we will get one vacant orbital. This electron is jumping to here. Okay, now I am taking the 3d 1 2 3 4 5 3d. Total how many electrons students? 8 electrons. So 3d 8. So 1 2 3 4 5 6 7 8. Now here we will get one vacant orbital because of strong field ligand. Cn is strong field ligand. That's a 3d electrons pair up. Already paired, these are unpaired, this also will get paired because of strong field ligand. Are you understanding? So it is a strong ligand. Are you clear? This is the strong field ligand. Okay, so paired. Here one vacant orbital we got, and 4s as it is you take none. Now for how many ligands are there, you have to identify. 4 ligands are there. So that's a 4 ligands are donating the 4 pairs of electrons to the central metal atom. That's a nickel required total 4 vacant orbitals because each ligand donating 1 pair of electrons. Correct? So that's why nickel requires total how many? 4 vacant orbitals required to accept the 4 pairs of electrons from the 4 ligands. Okay, here 2 vacant orbitals there already. Still how many required? 2 vacant orbitals required because 4 ligands there, 4 vacant orbitals required. If suppose here 6 there, here in nickel also 6 vacant orbitals required. So here 1 2, still 2 orbitals required. So I am taking it is a 4th shell, valence shell. I am taking 4p, it is completely vacant orbitals, 4p. So here how many required? 4 only required. 1 2 3 4. That means here we required only till here. Are you understanding? This last orbital we no need to take. Okay, Nama. So this 1 2 3 4, these orbitals are undergoing hybridization, students. So that means here d orbital 1, correct, 1 d orbital plus 1 s orbital, 1 2 p orbitals, total 2 kada. 1 ఏమో d orbital, 1 s orbital, 1 2 p orbitals. Are you understanding? These orbitals are undergoing hybridization, students. Are you clear? These orbitals are undergoing hybridization, produces, students, total how many? 1 plus 1 2, 2 plus 2 4, 1 2 3 4, total 4 now. So what we will get here? 4 d how many? 1. S how many? 1. P how many? 2. dsp2. Are you understanding? 4 dsp2 hybrid orbitals. Understanding, students? Hybrid orbitals are produced. Now these hybrid orbitals I am writing in one place. Now see here, these 4 boxes one place, 1 2 3 4. These 4 sp3d2 hybrid orbitals in writing in one place, and last one orbital you have to write separately, Nana. Okay, now see here I am writing as these 4 boxes like this. This is 3d and 1 2 3 4. These 4 dsp2 hybrid orbitals write in one place only, 4 boxes like this. These are dsp2, 4 dsp2 hybrid orbitals. Next here one more box is there, that is 4p na, that you have to write separately. Clear? So like this you have to take, Nana. Next, Nana, now these hybrid orbitals undergoing overlapping, students. Overlapping. These orbitals, which one, students? Ni plus 2. Okay. Now these orbitals of nickel central metal atom hybrid orbitals are undergoing overlapping with the filled orbitals of ligand, students. That means central metal atom orbitals, hybrid orbitals. See here, hybrid orbitals. Total how many are there? Hybrid orbitals 4 kada. So total 4. These are undergoing overlapping with the, okay, overlapping with which orbital, students? 4 cyanide orbitals. Are you understanding? Nickel orbitals, hybrid orbitals undergoing overlapping with the 4 orbitals of cyanide. Okay, now 4 filled orbitals of cyanide. Orbitals overlapping with the 4 filled orbitals of 4 cyanides. Clear? So here these hybrid orbitals are undergoing overlapping with the 4 cyanide orbitals. Okay, 4 cyanide orbitals. This word is important, students. Overlapping word you have to remember. This is overlapping. Here hybridization. This word is important. Are you clear? Hybridization. Okay, this is overlapping, right? Now, whenever central metal atom and ligands are undergoing overlapping, students, what happened? Ligands are donating the electron pairs to the central metal atom, 4 vacant orbitals. Now, see here, 3D here electrons now took na total 4 pairs na 1, 2, 3, 4, 5, 6, 7, 8. This as it is I took here, right? Now, these orbitals, these hybrid orbitals, so undergoing overlapping with the filled orbitals are 4 cyanides. Now I am taking this orbital structure. See here, 3D, total 4 boxes, 3D. It is completely filled, 4 pairs, and these hybrid orbitals 1, 2, 3, 4. 1, 2, 3, 4. Okay, these are electrons. Electrons of which one, students? Ligands. Electrons of ligands. Okay, electrons of ligands. So 4 ligands are donated in the 4 pairs. Okay, so here nickel, it is having the 4 vacant orbitals, so it is accepting the 4 pairs of electrons. So here these electrons, 4 pairs given by ligands, electrons of ligands. Okay, here completely vacant, here filled. Who gave this electrons? So ligand gave. Are you understanding? Ligand gave. This 4p, no need to write, students. Directly you can, no need to write, or if you write also, no problem. I am taking this 4p also as it is. Okay. Completed. Now we have to write the conclusion, students. What are the conclusions? See here. First one, hybridization. Tell me, students, what is the hybridization here? DsP2 hybridization. This only na, DsP2. What is the hybridization? DsP2. DsP2 hybridization. What is the geometry, students? Geometry. DsP2 hybridization means what is the geometry? See here. DsP2 geometry is square planar. Square planar, students. In the last video I discussed this one. Okay, once go through that. See here. DsP2. What is the shape, students? DsP2 square planar. Square planar, right? Next geometry, after what we have to write, Nana, magnetic property. So what is the magnetic behavior, students? Given complex, paramagnetic, diamagnetic, it is completely depends on 3D electrons, students. 3D electrons, see here, all are paired, all paired na. So paired means which one, students? Diamagnetic. Paired means diamagnetic. If suppose any unpaired electron is there, what you have to write? Unpaired electron is there, that is paramagnetic, students. Diamagnetic, because 3D electrons are paired. 3D electrons paired now, that's why it is diamagnetic, students. Are you clear? Next, it is outer orbital complex, inner d orbital complex. It is easily you can identify, students. Sp, first in hybridization, which orbitals there? D orbitals. So starting d orbitals are there, that is inner d orbital complex. If suppose after sp d orbitals there, okay, that is outer d orbital complex. This is inner, starting d orbitals there, inner. If d orbitals are present after sp, that is outer d orbitals complex. Are you understanding? Inner d orbitals, because in the hybridization, inner shell, third shell d orbital is involved in the hybridization. That's it, is inner d orbital complex. Clear? It is inner d orbital complex. Clear? It is inner d orbital complex, students. Understood, Amma? So this is about the complex compound. I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you, students.